Welcome back, students of Trig and Pre-Calc who are looking to learn solving trig equations. All right, so this is the second, I think, video we have done about solving trig equations. It could be the third, it's possible. But in the first one, I go into a good bit of detail about how important the instructions are to know what type of answer you're supposed to get. So if you haven't already seen that, you might want to look at that. And the first one we're going to do today is one that has the directions that say find all solutions. And the directions are just really important on these because they give you a lot of guidance as to what your final answers need to be like. So all solutions. Now, that importance doesn't really come into play until the end of the problem. It's more of a how do I write my answer, what kind of answer do I give thing. At the beginning of the problem, you're basically just trying to get the sign of x, in this case, alone, so that you can then figure out what x would need to be. So let's go ahead and just start doing that. I have an expression on each side that has to do with the sign. I have an expression on each side that has to do with just a plain number. And I don't know if I'm going to be able to keep going because my dog is barking, but hopefully it's she is barking at he, the cat. So excuse my pronoun mess up there, but hopefully that will stop pretty quickly. But I'm going to go ahead and combine my sign expressions on the left-hand side of the page, or left-hand side of the equal sign, as so. And that gives me 2 sine of x on the left. And then I'm going to combine my numbers on the right. Negative 3 root 2 plus 4 root 2 is positive 1 root 2. And that's where I am. Okay, so I'm going to pause this for 1 sec, take care of the dog, and come right back. Okay, I am back, and hopefully with a lot less barking going on. So here we are. We have gotten to where the sign expressions are together on the left and the numerical part is together on the right. But I still have a 2 out in front of that sign I want to get rid of. And I get that. And sine of x being root 2 over 2, well, that's actually a pretty common unit circle value. So I know exactly where that happens. I know that the sine is equal to root 2 over 2. Remember, the sine is the y. So that's at 45 degrees or at pi over 4 in radians. And I know the same thing happens over here. Okay, square root of 2 over 2. And that is 135 degrees or 3 pi over 4 in radians. All right, so those are basically my answers at this point, is that x equals pi over 4 and x equals 3 pi over 4. All right, so here is where the importance of the directions and the type of answer I'm supposed to give, that comes into play. This says that I need to find all solutions. Well, every single solution is not represented right here. If I were to take this point, this particular angle right here, this is the terminal side of the angle. If I go all the way around the circle again, I'll get to the same place, and that'll have the same value, same sine value, same sine and cosine value. But in this particular case, we're looking at the sine value. So in other words, all the way around the circle is 2 pi. So if I add 2 pi to pi over 4, 2 pi is the same as 8 over 4 times pi, because 2 is 8 over 4. So this could also be said to be 9 pi over 4. At 9 pi over 4, I have a sine value of root 2 over 2. If I go all the way around the circle again, so in other words, all the way around twice, that's what? 17 pi over 4. Go all the way again, 25 pi over 4. Every time I go all the way around the circle, I get back to that spot again, and yes, I'm at a location that has a sine of square root of 2 over 2. That also happens if I go backwards. If it's happening at positive pi over 4 and I go backwards 1 rotation, go in the negative direction, that's negative 7 pi over 4. Okay, I subtracted 8 over 4 pi, and the 8 over 4 comes from the fact that 2 pi is all the way around the circle, and if I want to write that with a 4 on the bottom, 8 over 4 is the same as 2. So pi over 4 minus 8 over 4 pi is negative 7 over 4 pi, or negative 7 pi over 4. Negative 15 pi over 4, negative 23 pi over 4, negative 31 pi over 4. I can keep going around and around and around however many times I want to go around the circle, which means however many times 2 pi. And I'll get to another one that has that same value, another place, basically another angle that has the same terminal side and therefore the same sine value. So here's what we do to that answer. We take that answer and we say pi over 4 is one place that has this value, but I can also go around the circle, all the way around the circle, however many times you want. Sometimes we use an n here, sometimes we use a k here. I'm using an n here just because I saw that on a test that my pre-cal students are going to take, I saw that they're going to use an n. So I usually use a k. It doesn't matter. The point is this is however many times I want to go all the way around the circle. So it could be negative 2 times all the way around the circle, or positive 3 times all the way around the circle. They'll end up, the terminal side will be in the same place. They're called coterminal angles because you go all the way around the circle, you get to the same place, and it'll have the same value. So I just write that for each of them. Okay, so plus 2 pi, however many times, positive or negative. N could be positive 1, positive 2. It basically just has to be an integer, positive or negative integer. Now, I left some space here specifically because I gave you my answer in radians. What if you were asked to give your answer in degrees? There was really nothing in this particular problem that indicated I should do it one way or another, so I chose radians. That's kind of a good default. But let's say you were asked to do it in degrees. Well, 45 degrees. Well, with degrees, all the way around the circle isn't 2 pi, it's 360. So I would say plus 360 n. Really, I would put the degrees on the whole thing. So this would be 135 plus 360 n degrees. Means the same idea. Okay? So in radians, I have 2 answers. This one and this one. In degrees, I have 2 answers. Let me point out one thing. Sine and cosine come back to the same spot with the same values, basically. Your values repeat every once around the circle. So 2 pi or 360. So do secant and cosecant because they go with sine and cosine. But tangent and cotangent, you only have to go halfway around the circle to get to another angle that has the exact same tangent. So if this had been a tangent equation, instead of saying plus 2 pi times n, I would have said 1 pi times n. Instead of 360, I would have said 180. Because 1 pi or 180 is halfway around the circle. Otherwise, it's pretty much this every time. If it's sine, cosine, secant, or cosecant, if you're in radians, you write plus 2 pi n or plus 2 pi k if you're using k. And if you're in degrees, man, I picked a bad pen. If you're in degrees, you write plus 360 n or plus 360 k, whichever one your teacher wants you to use. All right? So all says I need to add the part about n or k. I need to add the part about going all the way around the circle is going to get me to another location that has the exact same solution. Now, the rest of the ones we're doing tonight are not all. This is another type of directions you might be given, says on the particular interval from 0 to 2 pi. So that's basically saying within one rotation of the unit circle. Okay, so you just have to give those angles that happen in one rotation of the unit circle. And the other thing that you're being told here, I'm being told, I had to focus for a second, that I want my answers in radians because this is guiding me to radians. And I'm also told that if my answer is 0, 0 and 2 pi are the same thing. The open parentheses, or the parentheses, says this is the open interval on this side, which means 2 pi is not included. Bracket says that's a closed interval, so that means 0 is included. So if my answer were 0, I would say 0, not 2 pi. All right, so let's look at this one. This one, how I write my final answer might be a little bit easier, but I have to do a little bit more to solve the problem. So on this one, what you need to notice is that this is basically saying cosine of x squared plus 2 times the cosine of x plus 1 equals 0. And what you need to see there is that that's a very common format that we're used to using, but we're not used to using it with sine, tangent, cosine, etc. We're used to using it with a polynomial. It's basically like, and I don't want to write it on there, it's basically like x squared plus 2x plus 1. Something squared plus 2 times that same something plus 1. So just like I would probably do if I saw this, I am going to factor. Now, how I'm going to factor with this is I'm actually going to let something else stand in for cosine of x. I could use a, I wouldn't use x because x is already in the problem. I could use pretty much any letter, but it's very common to use u in situations like this and when you get to calculus. So I'm going to use u. So what I'm going to do is I'm going to solve for u, pun intended, and I'm going to do that by factoring. And I don't have to set each factor equal to 0 because they're the same. So either way, I'm going to get u is -1. And once I've got it isolated, once I've got u isolated, I'm going to say, oh, now let me go ahead and go back and look at what u actually stood for. U stood for cosine of x. So I'm going to say, oh, okay, cosine of x equals -1. And I'm looking for where on the unit circle does cosine of x equal -1. Well, the only place cosine of x equals -1, remember cosine is your x, so you go -1 to get right here, which is at pi. So my answer is x equals pi. A lot of times you have two answers. This time you only have one. All right, next up. And on a lot of these, you're going to be asked to factor, but let's look at this one. If I saw this problem right after I did the previous problem, my instinct would be exactly that. I want to factor. Another reason I want to factor there is because this looks a lot like the difference of two squares, something squared minus something squared. And I think, oh, well, I know how to factor that. It's like this. Here's the problem. If I were to do that here, I would end up with sine minus cosine, cosine minus sine, and just like, sine plus cosine, just like any other type of equation I'm solving, it is not helpful to have two different sort of variables. It's kind of like our variables are sine of x and cosine of x. It's not helpful to have two different types of trig function in the same equation. What I would much rather have is just one type of trig function. So what I'm going to do instead is I'm going to think about whether there is a way, without factoring, if there's a way to either rewrite this part in terms of cosine or rewrite this part in terms of sine. And absolutely there's a way. We know that, what's this? Need a new piece of paper. We know the Pythagorean identity, sine squared plus cosine squared equals 1. And when we have that identity, what that tells me is not just what this, it also tells me if I were to subtract sine squared from both sides, I would still have an equation. So meaning this must also be true. Or if I subtracted the cosine squared from both sides, I would still have a true equation. So this must also be true. So really all of these are identities. All of these are things that are always true, so I can use them. So what I think I'm going to do is I'm going to use this one. And I'm going to go up here and take sine squared of x, which is right here, and instead of writing sine squared of x, I'm going to write this stuff. Because then I'll have everything just in terms of cosine. So let's do that. So sine squared of x becomes 1 minus cosine squared of x. And then I still have over here minus cosine squared of x. So this becomes 1 minus 2 times cosine squared of x. So now I'm going to get my cosine squared of x alone. And this is what I have. Now, I don't have cosine alone, which is what I want. I have cosine squared alone. So just like any other time, if I have something squared and I want it unsquared, pull out yield square root. I'm going to take the square root of both sides, which gives me a plus or minus. So don't forget about that. So now I have the cosine on the left equals the plus or minus, the positive or minus square root of 1/2, which I'm going to simplify it a little bit up here, just so that I don't have to keep rewriting the whole thing. That's the same as this, which is the same as 1 over square root of 2, which finally, if I rationalize that, look at what it is from the unit circle. Okay, so that's square root of 2 over 2. So I want to know where cosine is equal to positive or negative square root of 2 over 2. Well, that's basically right in the middle of every quadrant. So right here at pi over 4, 45 degrees, cosine is positive square root of 2 over 2. Right here at 135 degrees, or 3 pi over 4, it's negative root 2 over 2. Right here, negative 2 over 2, negative root 2 over 2, excuse me. And right here is positive root 2 over 2. Now you might recall that sometimes when we're looking for really kind of an inverse, in other words, I'm told what the answer is for the cosine and I'm asking to go backwards. I'm asking what angle gives me that answer. We sometimes use in the fourth quadrant, we don't actually use fourth quadrant values. We use negatives from the first quadrant, like a reflection of the first quadrant. Here's how I know to use this and not call it negative pi over 4, is because this is how it was told to me. I was told to go from 0 to 2 pi. So they want answers that are between 0 and 2 pi. Negative pi over 4 is not there. Okay, so I want to consider this basically the quadrant that I am almost to 2 pi in. So that's 7 pi over 4. So my answers are pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Now, the reason it's that simple is I was just asked to give the ones that are between 0 and 2 pi. If I had been asked for all solutions, I would have to space these out and write this plus 2 pi times k, this plus 2 pi times k, this plus 2 pi times k, and this plus 2 pi times k. But I wasn't asked for all solutions. I was just asked on the interval 0 to 2 pi. Okay, now I think that's a pretty good stopping point for here. I'm going to give you another video with some more examples of solving trig equations, so you can look forward to that, look for that. And thanks for joining us. I hope it helped, and I'll see you later.